Hello all, I am Sindhu C. In this video lecture, I'll be discussing the basics of file management in C. Now, when I say the basics, generally we open a file, write some content in it, and we close it. So the file content is there. The same thing now we are trying to do it using a C code. Now, what is the necessity for using a C code to write some content into a file is, consider you have to make a transaction using an ATM. You're going to an ATM, you are inserting a card, trying to take 500 rupees out of it, and you complete the transaction, you come back. Now, this content, which is the withdrawal of 500 rupees, is automatically recorded somewhere, right? So, can be considered an example of how, without opening a file manually, putting some content into a file. So this putting the content into a file cannot be just done as such. You will have to create a file. Creating a file needs some structuring of the file, and then you have to put the content into it, and further more processing, if you have any, you will have to do it, and finally you will have to close the file. So this is the basic operation which we do in file management in C. Similarly, we have few other operations. So we are going to see how it is to be handled in C. So in this lecture, we'll be covering all these topics, which is the overall file management in C. How do we do it? How to define and open a file? How to close a file? What are the various input-output operations on files? What are the various measures, how to handle errors during input-output operations on files, and how to randomly access a part of the file, and finally, what is command line argument and how do we use it. Concept of files to store data. So we all know that a file is a place on the disk where a group of related data is stored. So C supports a number of functions which can perform basic file operations like naming a file, opening a file, reading data from a file, writing data to a file, and if all the operations are performed, closing the file. And file operations can be done in two ways. The first one is at a lower level, which is low level input output operation using unique system calls. The second one is high level input output operation using C's standard input output library. Here is a list of high level input output functions available for file operations. The first one is fopen, which creates a new file for use. If the file already exists, it opens for use. The second one is fclose. It closes a file which has been opened for use. The third one is getC, which reads a character from a file. Then you have putC, which writes a character to a file. Then you have fprintf, which writes a set of data values to a file. Then you have fscanf, which reads a set of data values from a file. getW, which reads an integer from a file. putW writes an integer to a file. fseek sets the position to a desired point in the file. ftell, it gives the current position in the file in terms of bytes from the start. Rewind is a function which sets the position to the beginning of the file. Here you can see that getC, putC, getW, putW, all these four functions deals character by character, whereas fprintf and fscanf, they deal with a set of data values. Defining and opening a file. In order to open a file, the file should be available, which is you should create a file. In order to create a file, you should define the properties of that file. So as it is said, if we want to store data in a file in the secondary memory, we must specify certain things about the file to the operating system, which is as such is the properties of the file. So the properties here are the file name, its data structure, and the purpose of the creation of that particular file. File name, it is the first important property of a file. File name is a string of characters that make up a valid file name for the operating system. It may contain two parts. The first one is a primary name. The second one is an optional period with an extension. So here are few examples where prog is the primary name and .c is the extension. Student is the primary name and .c is the extension. Similarly, hello is the primary name and .txt is the extension. Data structure is the second important property of a file. Data structure of a file is defined as file in the library of standard input-output function definitions. All files should be declared as type file before they are used. Here, file is a defined data type. When we open a file, we must specify what we want to do with the file, which is, do you want to read the file, or you want to write some content to the file, or you want to append some content to the already existing file. So this is to be specified, what you're going to do with the file. Here you have the general format for declaring and opening a file. So file is the keyword which is written in caps. Then you have a pointer variable. Here it is fp. In the second statement, you are assigning some properties of a file to that pointer variable. So what you are assigning here is fopen. Fopen is a function and it takes two arguments. One is the file name. The second one is the mode in which you are opening that particular file. Here, fp is declared as a pointer variable pointing to the data type file. File is a data structure that is defined in the input-output library. Fopen is a function which opens the file which is named file name and assigns an identifier to the file type pointer fp. This pointer, which contains all the information about the file, is subsequently used as a communication link between the system and the program. Purpose. Purpose is the third property of a file. Here you have the statement fp is equal to fopen file name comma mode. So here mode specifies the purpose of opening the file. The mode can be one of the three, which is R, W or A. R is opening the file for reading only, which is only read mode. W is opening the file for writing only writing. A is for opening the file for appending or adding data to already existing content. Now you should note that file name and mode are to be specified as strings, which is enclosed in double quotation marks. What happens when we open a file? When the mode is writing, which is W, a file with a specified name is created if the file does not exist. The contents are deleted if the file already exists. Now, when the mode is A, which is when we are opening the file for appending, the file is opened with the current contents safe, which is it is not deleted. A file with a specified name is created if the file does not exist. The third case is if the purpose is reading, which is we are opening the file in mode R, and if it exists, if that particular file exists, then the file is opened with the current content safe. Otherwise, if the file doesn't exist, an error occurs. Here we have an example. File star P1 star P2, which is you have two pointer variables. To the first pointer variable, you are assigning fopen data comma r, which is you are opening the file data in read-only mode. If the file data exists, then it is open for reading. If the data file does not exist, then an error is thrown. In the second statement, P2 is equal to fopen results comma w. We are opening a file results for reading. If the file already exists and if there is some content in it, it will be opened for writing, but all the contents in it will be erased. If the particular file results is not available, then a new file is created and it is opened for new contents to be written on it. Additional modes of operation. There are many compilers which includes these additional modes of operations. So the additional modes are R plus, W plus and A plus. R plus is the mode where the existing file is opened to the beginning for both reading and writing. W plus, it's just the same as W except that it's opened for both reading and writing. A plus is same as A except that it's open for both reading and writing. Now we should note that we can open and use any number of files at a time. However, it depends on the system we use. Closing a file. So when do we close a file? As soon as all the operations related to that file is over, we close the file. What happens when we close a file? So all outstanding information associated with the file is flushed out from the buffers. The second thing is all the links to the files are broken. The third, accidental misuse of the file is prevented. Then when there is a limit to the number of files that can be kept open at a time, closing of all unwanted files might help open the required files. Finally, when we want to reopen the same file in a different mode, then this might come of help. So the input-output library supports a function to close a file, which is fclose. So the syntax is fclose. Inside the parenthesis, it takes the argument, which is the file pointer, which is to be closed. So here we have an example, file star p1 star p2, which is you have two pointer variables. To the first pointer variable, we are assigning the properties of the file input, which is opened in write mode. To the second pointer variable p2, we are assigning the properties of file output, which is opened in read mode. Now, when we close the file input and outputs properties using the file pointers, we just give that file pointers as the argument to the function fclose. So fclose p1 closes the file input which is opened in write mode. Similarly, fclose p2 closes the file output which is opened in read mode. Once a file is closed, its file pointer can be used for any other file. Now, all files are closed automatically whenever a program terminates. However, closing a file as soon as you are done with it is a good programming habit. Next comes the various input-output operations that can be performed on files. So whenever a file is opened, reading out of it or writing to it is accomplished. So generally we use standard input-output functions. So we have these three categories: getC, putC functions, getW, putW functions, and fprintf and fscanf functions. The getC and putC functions. So these are the simplest file input-output functions. It is analogous to getChar and putChar functions, and it can handle one character at a time. Let us consider a file which is opened in write mode with a file pointer fp1. Now putC inside the parenthesis C comma FP1, which is it takes two parameters C and FP1. Now what happens when you give this statement is it writes the character contained in the character variable C to the file associated with the file pointer FP1. getC is a function which is used to read a character from a file that has been opened in read mode. So let us consider a statement C is equal to getC fp2. So this statement reads a character from the file whose file pointer is fp2. The file pointer moves by one character position for every operation of getC and putC. Now this getC returns an end of file marker which is EOF when end of the file is reached. Therefore, the reading should be terminated when end of file is encountered. The second set of functions is getW and putW functions. These are integer oriented functions. It is similar to getC and putC functions and are used to read and write integer values. They are useful when we deal with integer data. So the general form is putW and it takes two parameters. One is the integer, then the file pointer. GetW takes in one parameter which is the file pointer. So this putW is used for putting the integer value which is given in the first parameter to the file which is opened in a particular mode using the FP pointer. Now getW is used for getting the data from the file which is opened using the FP pointer. The fprintf and fscanf functions, unlike getC, putC, getW, putW functions, which can handle only one character at a time, these functions, which is fprintf and fscanf functions, they can handle a group of mixed data simultaneously. They perform input-output operations that are identical to the familiar printf and scanf functions, except that they work on files. So these work for files and those work for terminals. The first argument is a file pointer which specifies the file to be used. So let's take the general form, which is fprintf. Here you have three parameters, fp, then you have the control string and the list. fp is the file pointer associated with the file that has been opened for writing. Control string is the one which contains output specifications for the items in the list, as you know, which is %d or %s, %c, all that. List, it may contain variables, constants, and strings. In the forthcoming slides, we'll see some examples. So here is an example for fprintf. Fprintf, the first parameter is f1, which is a pointer variable. Then you have three control strings, %s, %d, and %f. Then you have three more parameters, which are the name, age, and 7.5. So this name corresponds to %s, age corresponds to %d, and 7.5 corresponds to %f. So here say name is an array variable of type character and age is an integer variable. So that is fprintf. Now let us consider fscanf's general form. It takes three arguments. fp is the file pointer variable. Then you have control string and a list. So fscanf helps in reading the list of items from the file specified fp according to the control strings. So the example, fscanf, f2 is the pointer variable, then you have the control strings %s and %d. Now you have two other arguments where item corresponds to %s and quantity corresponds to %d. Like scanf, fscanf also returns the number of items that are successfully read. When the end of the file is reached, it returns the value EOF, which is end of file. Error handling during input-output operations. So there may be several kind of situations where error happens when you process with input-output in a file. So the typical error situations include, the first one is trying to read beyond the end of file mark. The second can be device overflow. The third can be trying to use a file that has not been opened yet. Then trying to perform an operation on a file when the file is opened for another type of operation. The other can be opening a file with an invalid username or attempting to write to a file which is write protected file. So these are the typical error situations. Now, what happens if we fail to check such read and write errors? So the program may behave abnormally when the error occurs. It may result in a premature termination of the program. It may give out an incorrect output. So all these can happen. Now what can be done? We have two status inquiry library functions, which is feof and ferror, which are available in C library, that can help us detect input-output errors in the files. So here's the first function, the feof function. So it can be used to test for an end of the file condition. It takes a file pointer as its only argument and returns a non-zero integer value if all of the data from the specified file has been read, and otherwise it returns a 0. If fp is a file pointer that has just been opened for reading, then here you have the snippet, if feof fp, then printf end of the data. So this would display the message end of data on reaching the end of file condition. The second is the ferror function. It reports the status of the file indicated. It also takes a file pointer as its argument and returns a non-zero integer if an error has been detected up to that point during processing. It returns 0 otherwise. So here you have an example. If ferror fp is not equal to 0, then it prints an error has been detected. So if reading is not successful, this error statement will be printed. An error has occurred. Now, when a file is opened using fopen function, a file pointer is returned. If the file cannot be opened for some reason, then the function returns a null pointer. Now this facility can be used to test whether a file has been opened or not. So here is the snippet. If fp is equal to null, then print if a file could not be, the particular file could not be opened. Random access to files. So far all we have done is to read and write data sequentially with a file. Sometimes we may want to access only a particular part of a file and not reading all the other parts. So to achieve this, we have three functions which are available in the input-output libraries, which is fseek, ftell, and rewind. Ftell is a function which takes a file pointer and return a number of type long that corresponds to the current position. It is useful in saving the current position of a file, which can be used later in the program. Here you have the general form. N is equal to ftell fp, where fp is the pointer variable. Here n gives the relative offset in bytes of the current position. Now this means n bytes have already been read or written. Rewind. It's a function which takes a file pointer and resets the position to the start of the file. It also helps in reading a file more than once without having to close and open the file again. So here you have an example. Rewind fp. Here fp is the file pointer. n is equal to f del fp. So this would assign 0 to n because the file position has been set to the start of the file by rewind. Now also note that the first byte in the file is numbered as 0, the second is numbered as 1, and so on. So whenever a file is opened for reading or writing, a rewind is done implicitly. fseek, it is a function which is used to move the file position to a desired location within the file. Here you have the general form fseek, then you have three parameters. The first one is the file pointer, then you have offset, and then the position. So file pointer is the pointer to the file concerned. Offset is the number or variable of type long which specifies the number of positions in bytes which is to be moved from the location specified by the position. Now this offset can be positive, which means move forward, or negative, which means move backward. Here position is an integer number. Now this position can take one of the three values. 0 means beginning of the file, 1 is current position, and 2 is end of the file. Here we have few examples of the operations on fseek function. So we now know fseek has three arguments. The first one is the file pointer, the second one is offset, and the third one is position. In the first three rows, you can see that position takes the value 0, which says go to the beginning. When the position says 1, it says stay at the current position. When it is 2, it says go to the end of the file, past the last character of the file. Now, when you have the offset m, it says move to m plus 1th byte in the file. When it is m and the position is 1, it says go forward by m bytes. When the offset is minus m and the position is 1, it says go back by m bytes from the current position. When the offset is minus m and the position is 2, it says go back by m bytes from the end. So these are few examples how it can be seeked. So if the operation m is successful, fseek returns a 0. If we attempt to move the file pointer beyond the file boundaries, an error occurs and fseek returns -1 value. Finally, command line arguments. So what a command line argument is it is a parameter supplied to a program when the program is invoked. This parameter may represent a file name the program should process. So here you have an example, program x file y file. So this executes a program to copy the contents of a file named x file to another one named y file. Here program is a file name where the executable code of the program is stored. This eliminates the need for the program to request the user to enter the file names during execution. Now, how do these parameters get into the program? So we have seen program X file, Y file. So these parameters, how do they get into the program? For every C program, one main function is mandatory, which marks the beginning of the program. Only one main function is there and it is mandatory. Now, main function also takes arguments like any other function. Main function can take two arguments, which is argc and argv. The information contained in the command line is passed on to the program through these arguments when main is called up by the system. The variable argc is an argument counter that counts the number of arguments on the command line, and the argument argv is an argument vector which represents an array of character pointers that points to the command line arguments. the size of this array will be equal to the value of argc, which is the argument counter. Now here is an example which explains all of that we have seen in the previous two slides. So here program x file y file. Here argument counter is 3 and which is program x file and y file, you have 3. Argv, which is the argument vector, is an array of 3 pointers to strings, as the first one is program, the second one is x file, and the third one is y file. In order to access the command line arguments, the main function and its parameters should follow. So inside the program you have main and it has two parameters, int argc, and char you have the pointer variable which is an array variable argv. Now only if you have these arguments for your main function, you will be able to access the command line program x file y file. So this is how you access command line arguments using your main function arguments. So far in this lecture we have discussed what are the various file operations and how to manage files in C. We have seen how to define and open a file, how to close a file, what are the various input-output operations on files, how to handle the various errors that occur during the input-output operations when we handle files. Then instead of accessing files sequentially, file data sequentially, we can also access data in files randomly. So we have seen random access to files, and also we have seen how to use command line arguments using the main functions arguments. So this is the main reference that I've used, Programming in ANSI C, 3rd edition by Professor E. Balagurusamy. Thank you. Good luck.